Hey everybody, welcome back. So today we're going to be talking about trig identities. And trig identities are really the closest thing we have to research mathematics in this course because they deal with proofs. So our goal for today is to see how do we actually prove a trig identity. Now there's not a procedure, or at least a procedure that's going to work for every single trig identity here. I'll give you some broad strokes on what you should try, but keyword there, try something, okay? Now, before we actually see how to do a trig identity, I want you to recall some identities that we have seen before. First, we have the quotient identities. Okay, so remember, tangent is sine over cosine, cotangent is cosine over sine. So these are things, by the way, these identities we're about to come up with, these are things you can assume to be true, unless we're trying to prove one of them. We have the reciprocal identities. So cosecant is 1 over sine. Okay, secant is 1 over cosine. Cotangent is 1 over tangent. Okay, so these are called the reciprocal identities. And some of the most important identities we have, Pythagorean identities, we have that 1 is equal to sine squared plus cosine squared. Secant squared is 1 plus tangent squared. And cosecant squared is 1 plus cotangent squared. Now, the reason why I'm bringing up all these identities, and again, things that we've seen before, we can use these when we're trying to prove other identities, assuming that we're not trying to prove one of these on their own. Okay. All right, so let's actually see. So keep these in mind, keep these in your toolbox. Let's see a trig identity and how to prove it. Okay, so first example, prove that secant squared is equal to 1 plus tangent squared. So again, notice that is one of our Pythagorean identities. It's that second one there. Okay, so we can't assume it's true. We're trying to prove it and actually show that it's true. Now, my first suggestion for you, whenever you're doing a trig identity, and this might seem backwards, the first thing I recommend is pick the harder side. Okay, pick hard side. And our goal, our objective is, once you pick the hard side, you want to make the hard side look like the easier side by using either algebra or the identities that we talked about above. Okay, so 2, make hard side look like the other side. Now, again, that might seem backwards that we're picking on the hard side, but usually with the hard side of a trig identity, you have more to work with. Okay. So in this case, what we're going to do is we're actually going to start with this side, 1 plus tangent squared theta. And the only reason why I'm picking that, it has more terms, so I'm thinking of that as the harder side. So when you're proving a trig identity, again, pick the hard side, and we're going to stick with that. Okay, so we're going to stick with 1 plus tangent squared theta. Okay, and we want to make it look like secant squared theta. So once we have secant squared theta, we're done. Okay. Now, again, with trig identities, there's no clear-cut way of doing it. You just kind of have to try something and then go with it, and there's multiple ways of proving an identity. One method that you can try that's usually pretty good, convert everything to sines and cosines. Okay, so I'm going to take tangent here, and using the quotient identity, we can replace this with 1 plus, so tangent squared is sine squared over cosine squared. Okay. All right, next thing, let's go ahead and use some algebra. Let's add these two things together. Now, the reason why we're going to do this, notice that we're trying to get secant squared, right? Which means we want one term. So one of the best things to do, if you have two terms like this, we'll add them, and then you're actually going to get one term. Okay, now how do I add these two things together? We need to convert 1 into cosine squared over cosine squared so that we have the same denominator. Okay, and now we can add them, and we're going to get cosine squared theta plus sine squared theta over cosine squared theta. Okay, now what do we know about cosine squared plus sine squared? Let's look back up at one of our most important identities here. Sine squared plus cosine squared is 1. So we can replace that numerator with 1. Okay. Now, using the reciprocal identity, what is 1 over cosine squared theta? That's actually secant squared theta. Okay, and notice that's exactly what we want. Okay, so this is what a trig identity is. A trig identity, again, is taking one side and making it look like the other by using either algebra, identities that we already know. And again, it highly depends on the trig identity. Okay, there's not a clear-cut way of doing every single trig identity. So try something. Try algebra. Try, again, in this case, we changed everything to sine and cosine. That's a pretty good way of doing things. But again, there's no clear-cut way of doing these. It just highly depends on what type of trig equation you're dealing with. All right, let's look at this example. Secant theta minus tangent of theta sine of theta is equal to 1 over secant of theta. Okay, so how are we going to tackle this one? Again, we're going to pick the harder side, and hopefully you all agree. I think the left-hand side looks a little bit more complicated than the right-hand side, so let's start with that. And I'm actually going to do the same thing we did last time. Let's convert everything to sines and cosines. So secant of theta here, this is 1 over cosine, minus tangent is sine over cosine. Okay, so let's multiply the two sines here. Okay, and we get 1 minus sine squared theta all over cosine of theta. Okay, now keep in mind we want 1 over secant of theta, right? Okay, so what else can we do now? Now notice on the top we do want a 1. We don't want any sine squareds, right? So let's use the Pythagorean identity here. Okay, we know that 1 is equal to sine squared theta plus cosine squared theta, right? So let's substitute this for 1. Okay, so this will be sine squared, oops, trying to color coordinate it for us. Sine squared theta plus cosine squared theta. Okay, minus sine squared theta over cosine of theta. Notice the sines cancel out, and we have cosine squared theta over cosine of theta. Okay, and we can cancel out one of these. And so we get cosine of theta. Okay. Now keep in mind, what are we trying to get? We're trying to get 1 over secant of theta. Okay. Well, notice that we have secant of theta is 1 over cosine of theta. Okay. So if we take that identity and we take the reciprocal of both sides, we'll get 1 over secant of theta is equal to cosine of theta. Okay, so here, what we can do with our trig identity, we can actually say that this is equal to, right off the bat, 1 over secant of theta, and we're good to go. Okay, so again, with this trig identity, what did we do? We started with the harder side, okay, which I think is the left-hand side in this case. We converted to sines and cosines. Again, that's a pretty good strategy for the most part. It doesn't always work, but it's a good strategy. And then we combined fractions. And then we use the Pythagorean identity to convert this 1 into sine squared plus cosine squared, which allowed us to cancel out the sines, leaving us with just cosines here. And then using the reciprocal identity, we were able to take what was left and convert it into what we wanted, 1 over secant of theta. Okay. So again, there's not a clear-cut way of doing every single trig identity. And there could be other ways that I'm not showing you right now. I'm not saying that this is the only way. But what I recommend you doing, again, try the hard side or pick the hard side and then just try something. Okay. Manipulate it into that last part of the equation. And for our last example today, let's look at cosine squared minus 1 sine squared theta is equal to 1 minus 2 sine squared theta. Okay, so we're going to pick let's pick the right-hand side. Do I want to do that? No, let's pick the left-hand side. There's more trig functions there. All right, so cosine squared theta minus 1 sine, oops. I mean, that is technically true, but I don't know why I wrote that. So let's pick that side. Okay, and we want to make it look like 1 minus 2 sine squared theta. So to do this, again, let's go ahead and think we want a 1, right? And what equation do we know, or what identity do we know that has a 1 and involves sines and cosines? We know that 1 is equal to cosine squared theta minus sine squared theta. Okay. Now we don't have a 1 in our equation yet, but notice that if we move sine squared over to the right, I'm sorry, to the left, we get that 1 plus sine. I'm sorry, whoa. Take a step back. I totally wrote down that identity wrong. So 1 is equal to cosine squared plus sine squared. And if we move the sine squared over to the left, we get 1 minus sine squared theta is equal to cosine squared theta. Okay, so let's substitute that into our trig equation. Okay, so cosine squared theta, that's going to become 1 minus sine squared theta minus sine squared theta. Okay, and now let's combine the sine squareds here. So this is equal to 1 minus 2 sine squared theta. And that's actually what we wanted here up top. We're good to go.